Okay, so for today, I want to discuss about the derivation of equation for mechanical torque in terms of parameter. So this equation is important in order to calculate the maximum torque and starting torque, as well as when we want to implement the speed control for induction motor. So we can start by looking at this equation. So the equation for mechanical power PM. So the mechanical power is equal to 3I2 squared R2 over S 1 minus S. And also in terms of torque and omega, so PM is equal to omega R times torque mechanical, where omega R is in this case is equal to the rotor speed in radian per second. And then when we compare between these two equations and solving for Tm, so Tm is basically equal to this whole equation divided by omega R. Next, we bring down the denominator of the top term. So we bring down this S, and we know that omega R is equal to omega S 1 minus S. Okay, so we can cancel the top 1 minus S and the bottom 1. So finally we have this equation. Okay, so we have the term for the rotor current I2. So basically we have to substitute I2 in terms of the equation for I2. So I2 is basically equal to V phase divided by R1 plus R2 over S plus J X1 plus X2. But now because we want to calculate the mechanical power, so we are focusing on the magnitude of I2 only. So we have to cancel the effect of the imaginary part. So how to do that? Okay, so we have to square both the denominator of the I2, and then we have to square root back the denominator, and then the effect of the imaginary part will be eliminated. And then we substitute back the equation for the magnitude of I2 into the equation of torque mechanical. So finally we will get this equation. By simplifying the above equation, so therefore the formula for the mechanical torque Tm in terms of the parameter is equal to Tm is equal to 3V phase squared over omega S multiplied by slip R2 over R2 plus S R1 squared plus Sx squared, where X equal to X1 plus X2. To calculate the maximum torque, we will use the equation of mechanical torque that we have derived just now. So we have two methods to calculate for the maximum torque. First method is by calculating first the value of maximum slip. By using this equation. So positive is for motor and negative is for generator. Then the value of this slip will be substituted to the equation of mechanical torque, and automatically the equation will give you the answer for maximum torque. Okay, the second method. So the second method is by using this equation. Okay, so this equation has been derived and simplified by substituting the equation of maximum slip to the equation of mechanical torque, and then we get this new equation. So straight away use this equation to calculate for maximum torque. Okay, so finally to calculate for starting torque, so basically at starting, slip equal to 1 because the speed of the rotor is 0. So when we substitute slip equal to 1 to the equation of mechanical torque, finally we will derive the equation for torque. So this is the final equation for torque starting. Okay, as a conclusion for this session, so today we have learned how to derive 3 equations. Okay, so for the first equation, so we have derived the equation for mechanical torque in terms of parameter. Then we have derived the equation to calculate the maximum torque. So we have two choices, whether we calculate first the maximum slip and we substitute the value of maximum slip to torque mechanical and will give you the answer for maximum torque, or the second option, we can straight away use this equation. In this equation we don't have any slip term because this equation have been substituted to this equation and have been simplified. Okay, finally we can calculate the value of torque starting by substituting the slip equal to 1. So you can see that when you compare between these two equations, so the difference is just in this equation we don't have any slip anymore because we have substituted the value of slip equal to 1.